So moving from scoping and screening into the actual risk assessment itself. So the conventional bow tie from a process safety perspective is that you've got some hazard, some operation activity or material that can cause harm. You control or contain that hazard, but when you lose control, the top event occurs and you have the potential for negative effects or consequences. The top event can be caused by a number of different threats, and you aim to prevent those threats becoming the loss of control by prevention barriers or countermeasures. And if and when you experience that top event, you aim to reduce or avoid the effects through mitigation barriers. So from a cybersecurity perspective, at the heart of it, you've got critical or sensitive or valuable data that you don't want to lose control of. You don't want it to be stolen or compromised or manipulated. So you put in place resistance measures, you put in place this detection and protection so that you don't experience it, but God forbid, when you do experience it, you've got that recovery in place, you've got the ability to get your data back up and get your facilities up and running with the minimum amount of disruption. So if we look forward to how that would appear on a process safety bow tie diagram, this is just a very simplified view. We've got hazardous material, we lose control, it could lead to harm to personnel through a major accident, it could lead to commercial problems through production interruption, or it could lead to damage to the environment. We have measures in place to prevent or mitigate them, but these measures may be vulnerable to either deliberate or accidental attack. So barriers that are related or connected to industrial automation control systems can be defeated or degraded. Or we could have threats that are created as a result of the attack, or existing threats become more likely because of that breach, because of that loss of data or integrity control. Now, the start for a self-assessment is, in our case, we've taken a specific appendix from OG86, which has 11 familiar or most common threat types. Most of these are malicious or deliberate attacks on your industrial automation control systems. We've simplified that in a simple bow tie format, and we're using the cyber assessment framework to identify the countermeasures that the HSE expect to see in place. So we've got barriers here, which are the countermeasures. We've got barrier types, whether they're protection or detection, and we've also got the threat types on the left-hand side. A really simple, we've called it a security hygiene check. Using this OG86 bow tie, you can simply evaluate the threats. Are they credible or not to my scenario or to my systems? Are the barriers present? Are the barriers absent? Do I actually know whether the barriers are there or not, or do I not really need those barriers? So a simple yes, no check is a really quick assessment of the robustness of your cybersecurity measures. And one of the useful things in BowTieXP is you can flag up any deficiencies by using these action post-its. So looking at your larger bow tie, if you find this is covered in yellow or red post-its, you know that you may have assessed it, but you've still got some work to do to make it as safe and secure as it could be. So that's a simple hygiene check. The next step is to dig a bit deeper and to better understand the risk by considering the likelihood of attack and the effectiveness of the countermeasures. So the likelihood of attack we've taken from the US NIST guidance, SP 830, which again, it's all freely available. And depending on the capability or persistence of the attacker, depending on the relevance or attractiveness of your assets, then you can get a good sense of what's the likelihood that you're going to experience an attack, who's going to be interested in your facilities. So we use that to give us a threat likelihood. The barrier effectiveness we get from the CAF scoring. So depending on your answers to the questions, to the self-assessment questions, do you fully, partially, or not at all achieve those objectives? And that gives you a sense of the effectiveness of those barriers. In a few minutes, I'm going to show you how this works in reality using BowTieXP, but this is a simple screenshot to show how you can implement the cyber assessment framework as a series of questions. You apply those questions, or you collect those questions in a survey, and then apply the survey to your system. So here we have 9 different systems or 9 zones within your automation and control system. So that question there, that B3.C, all those 9 surveys were all negative. I mean, generally when you look at the answers, they are more red than green. So that's giving you an immediate sense of my barriers, my countermeasures are not as robust or not as capable as I thought they were when assessed against this cyber assessment framework. Some are generally more positive than negative, but there are some weaknesses, and I'll show you in a few minutes how you get much more data on that from BowTieXP. Moving forward from your logical bow ties into your physical bow ties, so effectively a breach or a loss of control from your logical bow tie, your industrial automation control system, the consequence of that may become a threat to a physical bow tie. So it could lead to a loss of containment, in this case a flammable liquid, which if your barriers are not present or not performing, then could lead to these tangible consequences. These are real effects on people, on the environment, on your equipment, on your business. So we're chaining together these bow ties. Logical consequences become physical threats. Looking at this in a bit more detail, so this is an example of a zone. So this is a basic process control system zone. So we have a number of potential attacks or threats within the zone. They may be adversarial or malicious or deliberate, but they may be accidental. They may be structural because of equipment problems, or they may be environmental because you've got flood issues or lightning strikes or other things. So it's not just simply about the rogue nation states or the disgruntled teenagers in your bedroom. There are other things that could threaten your zone. The effects of that could be impacted on these physical assets. So these are individual bow ties for tanks, for example. So using the Buncefield example, these are all tanks in the Buncefield tank farms. The potential consequences, the major accident, essential services, environmental, reputation, etc., these can be scored on the diagrams, and those scores can then be aggregated to show the worst case outcome of a breach of that logical asset based on its potential outcome on these physical assets. So this bow tie chaining concept allows us to tie together these two bow ties, but also, which is really useful, this idea of zones being connected by conduits. Because we've got bow ties for each zones, chaining those zone bow ties together lets us see where an attack on this zone 5, for example, could be transmitted downstream to another zone, or conversely, an attack in another zone could pass through a conduit into this zone. So the bow tie chaining is not only logical to physical, it can also be logical to logical. And using the relationship diagram within BowTieXP, that can be summarized. It's a bit difficult to read, and you may need a microscope to get into the detail, but what it does show at a relatively high level, again, is the topology of it. It's showing that here, this system here has lots of interconnections, a bit like a tube map or a metro map. You've got lots of interfaces round about this bow tie here or this asset here. Less so coming in here. This is basically coming in from the internet, but you've got a sense here of the scale and complexity of the network that you are managing, that you are protecting, that you are defending. So taking that forward from the logical to the physical, we can identify on the physical bow ties where individual barriers are connected to logical bow ties. So here we've got these two barriers here that are influenced or overseen by a particular zone. So if we lose this zone 5, either deliberately or accidentally, then you've got a common cause failure. Both these barriers could be lost, and you've then got no protection or no prevention from this particular threat. Similarly, a breach of the zone could lead to a threat. It could disable a control loop or instrumentation loop, and that in itself could instigate this loss of containment and the effects of that. Another thing I'm going to show you later is how systems and parts are really powerful features of the software. So your barriers are made up of systems. Those systems generally are based on a detect, decide, and do, or detect, decide, and act concept. So your safety instrumented functions will have a sensor, logic solve, and a final element. Your alarms will have a sensor, a processor, and an operator or somebody else to carry out the action. What systems and parts allows you to do is to give you online status of the health of those parts. So if you lose a particular part, it could be the logic solve or it could be a sensor, that can then compromise the barrier, and the systems and parts overview allows you to see immediately when your barrier becomes unavailable, because it goes from green to red. So I'll show you that shortly. Before I move into the software demo, are there any comments or questions, any chats to Ariane or anybody else, anything that you want to know about before you see the software?
I don't see any questions in the chat either, so if no one's got questions, I just suggest we move on.
Okay, thank you. So here we have a set of bow ties. So I've created, again, using Buncefield as an example of a physical asset, using the HSE OG86 architecture for our logical assets. I've created bow ties for each zone within the within our system. So here, this was the example I was showing you before. So here we have Zone 5. Zone 5 is vulnerable to these threats: deliberate, accidental, structural, environmental. At a high level, you've got barriers in place that prevent the loss of integrity. Those of you who are familiar with BowTie good practice will know that management technically isn't a barrier. Management is supporting or enabling all these other barriers, but for simplicity and just to align with the cyber assessment framework, I've shown management as a barrier, and I've just given these nominal effectiveness: poor, good, very good, just to give you a sense of color, just to give it a bit of variety. So previous or prior to losing integrity or losing control, you've got these primarily protection detection measures in place. Once you've lost control, you've got your recovery measures in place that should slow down or reduce the escalation from the logical asset through to the physical assets. And as I mentioned before, these physical assets have their own severity rating, their accident, environment, services, commercial. Those can be migrated back from the individual bow ties back onto this bow tie to give you an overview of what's the physical significance or the physical criticality of this logical asset. Down here, we've got the breach. So conduit 5.4 breach, that's basically a breach from zone 5 to zone 4 through that conduit. And then up here, we've got the reverse. So you've got somebody or something breaching zone 4, which is allowed to pass forward into zone 5. So here you see, once zone 4 has been breached, you've got some recovery measures on the zone 4 side, which I've also shown on the zone 5 side, that are protecting, are stopping it getting further into zone 5. So that's the logical representation. The physical representation is here. So I've simply, again, just showed some representative barriers from the CCPS BowTie book, different combinations of humans and hardware. So having had a breach potentially from either zone 5 or zone 6, challenging the integrity or the containment of that tank, possibly leading to accidents, environmental damage, etc. So these severity scores here are aggregated here. They're then aggregated backwards towards the logical bow tie. So that's giving us a sense of the physical and logical criticality. Looking at this in more detail for the logical bow tie. So here we've got our 11 familiar threats. We've got the expected or the anticipated measures in place, and putting some more detail on it. Again, what is the likelihood of the threat? What's the effectiveness of the barrier? That's giving a sense of the robustness of our countermeasures. And here we have some actions to be implemented. If we look at this from an audit perspective, so using BowTieXP, I've created a number of questions. So these questions from the cyber assessment framework. So hopefully you can see that. So each of these objectives has a question. Do you meet the requirements partially, fully, or not at all? Depending on your answer, you get a positive or negative response. So here we have 9 surveys, 1 per zone. On aggregate, generally they're more negative than positive. The audit software allows us to drill into, if I want to see particular surveys. So I'm now down to 3 particular surveys. There's still, the 3 that are left are still very much negative. So I've got that sense of, I think I'm prepared, I think I'm ready for an attack, but the responses I've given or someone has given to my cyber assessment questions are not as reassuring as I would hope they would be. Then lastly, this is our major accident scenario. So this is a simple analysis. Again, I've used Bunsfield as an example. The Bunsfield report has a neat example of a layer protection analysis. So I've simply taken the LOPA example from the Bunsfield report, visualized it in a bow tie, and in this case I've categorized the barrier effectiveness: very poor, poor, very good, again just to bring some color to the diagram. But what's really important is the relationships with the logical assets. So these barriers are connected to different logical zones. So any compromise to those zones will have an impact to the barriers. And the way that's visualized is through systems and parts. So this systems and parts view is showing me here that I've got I've got a system with 3 parts in it. If I go to this part here, so my barrier here consists of effectively 3 parts. It's a safety instrumented function. I've got a sensor, a high level switch. I've got a logic solver, which is in zone 6, and I've got a final element, which is an isolation valve. If I lose one of these components, so if I lose zone 6 because it's become compromised, I need all these 3 parts to detect, decide, and act. So therefore, losing zone 6 has now compromised this barrier, and I've now defeated this because of a cyber attack. If I look at my other ones, my alarms here, my alarms are slightly different. So in my alarms, my detect, decide, and do, I've got a zone 5. So let's make zone 5 healthy again. I've got a level switch, and my doing or my acting is an operator. So let's bring the operator back online. So I've now got my 3 parts that make this barrier healthy again. If, for example, I've got, let's just say, a smart switch, so I'm losing my smart level switch has been attacked. I've lost that functionality. I've now defeated that barrier. And the worst case is, if I go back to this, I've got a healthy level switch, but because both these barriers are related to zone 5, if I lose zone 5 because of a cyber attack, I've effectively lost both those barriers. So I'm relying on zone 6 still being intact. If I go here, I'll put zone 6 back online. So I'm relying on zone 6 being healthy to give me at least some form of defense. So that's the bow tie chaining, that's the audits functionality within bow ties, and that's the systems and parts that's connecting the logical analysis to the physical analysis. So if I can resume where I was. So in conclusion, what this chase technique is, we're pulling together established tools. The screening and the scoping is simply done using Visio. We're using that to focus our efforts to develop logical bow ties for our industrial automation systems and physical bow ties for our processes and plants. We're using our existing risk assessment, so you already will have physical asset bow ties, your process safety bow ties, etc. But remember that some of your vulnerable assets, some of your utilities or ancillaries may not have a HAZOP, they may not have a process hazard analysis because they've not been deemed to be safety critical, but they are, you know, security critical or production critical. I'm not a cybersecurity expert, so what we've created is a framework to allow expertise in different areas to come together with a common framework, a common language, and pool their knowledge to visualize the scenarios, get a common understanding and a common approach. It can be done in stages. The OG86 framework is very much targeted to major accident hazards, loss of essential services, but it could be a quality issue, it could be a reputational issue. It's the same technique, it's the same principles, and you can do it in a scalable, organic way. And fundamentally, we're pulling together these different parties, these different stakeholders, the information technology, operational technology, and the physical technology, the IT, OT, and we're calling it PT. My friend Rachel has neatly summarized all this in one neat graphic. This is all Chase is doing. It's pulling together physical and logical assets, chaining together knowledge through graphical representation. And ladies and gentlemen, that's all I have to share with you. If you have any questions or comments, please type away, speak out. We're open to your suggestions, your comments, your questions. So thank you for listening. Thank you for watching. Do we have any feedback?